cheers, Chris, for hosting this event today and inviting us as Automata here. I'm Emma Norris. I'm the Strategic Partnerships Lead at Automata, and we are a company trying to revolutionize biology in the way that we use automation and technology. So I'm hoping to do two things today. The first is to convince you that your lab is really like a kitchen. And drinks on me afterwards if I haven't convinced you that by the end. And also give you a bit of a sense of the kind of impact that we're seeing that automation can bring to a couple of our partners over the last couple of years. So I've got two photos up here to start with. I don't know if anyone recognises the one on the left, a formidable female scientist. Marie Curie, exactly. And she's there, she's sitting there with a flat desk, couple of instruments, but writing manually, working away with a relatively small number of data points to try and generate insights. And you may recognize the left-hand side to be somewhat like how we do it today. I trained as a scientist in the labs. And this was what my life was like, working with pipettes, getting RSI, and having that challenge of constantly being limited by our own time, our own space, and the amount of manual repetitive work that we had to do. So just despite the fact that everything is so manual, the world that we live in now is one where pharma companies and biotechs like yourselves are wanting to start to drive AI and machine learning insights. We're wanting petabytes of data from some of the workflows. And what this means is that we need repeatability and reliability of data on a scale that we haven't seen before. And the other thing that lots of labs continue telling us, and obviously Scale Space is doing this brilliantly here in London, but is that particularly startups can't find lab space in that Oxford-Cambridge triangle. It's extremely expensive from a real estate standpoint. And then the third is about throughput requirements increasing. This one for me is most obvious in terms of the NHS's throughput and TAT requirements, so turnaround times for a lot of the diagnostic testing that we're seeing. So whether that's in cervical cancer screening or in cancer diagnostics, those demands on testing facilities are increasing hugely. So that's the new world, and what it's brought about is a new tech stack in labs. And at Automata, we're delighted to be part of this new group. You'll probably recognize a couple of these on the board. And when people ask me, what do we do as Automata, I say, we're kitchen designers. So what does a good kitchen designer do when they decide to work with you to make your kitchen? So you may decide, oh, I want to have the sink far away from the fridge, or actually maybe my wife likes taking something from the fridge and washing it in the sink, so I'm going to put that closer together. You may want to have somewhere where you cook eggs in multiple different ways. You have the same input, but you cook it in the oven or you cook it on the stove. You may actually want to switch this orientation around so that it's facing the sofas instead of facing the current orientation. And so this is kind of what I believe that we do at Automata. We try and design your lab as a kitchen designer would design your lab, design your kitchen rather. Hopefully they're not designing your lab. And there are three key design principles that we go by. So hopefully I'll take you through in the next couple of examples these three key things that we base our design principles on a platform, a modular approach, where you can build, you can take away, you can add devices, benches, robots. The second, which is that we really encourage human-robot interaction, and we think that that is the new paradigm for labs moving forward. And then the third, where the analogy with kitchens completely dies, is that data is important, and we need to make sure that data is the key thing that we drive when we talk about automation. So the first one, modular flexibility, this just gives you a little bit of a sense of all of the different designs that we come up with. You can have a CAS unit, or without a CAS unit, you can have robots at the front, robots at the back, robots in the middle. You can have long linear systems or back-to-back. And to give you a little bit of granularity about what that could look like, this is one of the clients that I am lucky enough to work very closely with. And this was the start of our journey with them. We were talking about an assay platform. So this platform currently does 2 assays, moving on to making it do 3 or 4. And it's a long and linear approach, right? You've got all of your different devices, all which do different things. We tend to off-deck from the liquid handler. So we take things like centrifugation or stirring or thermocyclers out of a liquid handler such that you have a more specialized activity happening on the bench, and that increases throughput and often increases reliability as well. And so you have all of these different devices which are facilitated by 2 robotic elements, the robots and then the transport layers that you can see underneath. So that's option 1. We then thought, let's go up. So this is exactly the same design, but moving upwards, so adding stacking. This was because we were struggling with the footprint in the lab, and we said, how can we fit as many instruments as possible on one system? So that was option 2. And then option 3 is something that we've worked very closely with this partner on, is moving the robots to the back of the system. And this is actually our first system where we've moved the robots at the back to increase human-robot collaboration. So this is Alice. We have actually scanned Alice so that she's a real person in all of these photos, which I quite enjoy. And she can interact with the system manually whilst a robotic workflow is going on using other devices. So what that means is that people can use their labs, use their equipment in the same way that they might otherwise do, whilst facilitating robot movements at the back of the system. A couple of other fun things here that we've also been looking into are some turntables. So that means that the instruments that have an entry point for a plate can either be facing the back or the front of the system, depending on if you want to use it manually or in automated mode. So that's kind of point 1 and 2. We've talked about flexibility, modularity, what you can do with adding things to a system. And we've also talked about this idea of human-robot collaboration. And then the third thing is data, and this will, I'm sure, be familiar to all of you, that obviously increasing data quality and quantity is key for labs. Our LINQ systems, what we call our benches and our platform, can pull a ton of different data points, and this just gives you a sense of what we're talking here. So you can start looking into temperature, humidity, CO2 level, etc. And the dream is to have that linked up to your LIMS, your ELNs, depending on whatever your customer or whatever you want the connectivity with. So why does this matter? With a parent actually in hospital currently, I thought I'd bring up this slide. This is about cancer diagnostics and our work at the Royal Marsden Hospital. So at the moment, manually, turnaround time for the hospital has been 21 days for cancer diagnostics. And with the work that we're doing with them, we're looking at a projected turnaround time of 7 to 9 days. So this is extremely exciting. It's a pressing issue in modern science. The likelihood that a positive cancer diagnosis is based on early diagnosis, and that's a critical component to the NHS over the next couple of years as the government targets are becoming more stringent in terms of turnaround time days. And this just finally gives you a sense of what that system looks like. We've seen the impact, and this is what it looks like in terms of the hardware. We have 2 systems at the Royal Marsden, the post and the pre-PCR systems. And the real beauty in this is the 3 times increase in testing capacity, whilst also reducing cost per sample by a significant amount as well. So that's really why I'm passionate about automation. Here's 2 kitchens that we've worked on. I'm really happy to answer any questions or join anyone for pizza at the back. Also have Callum at the back there, who's part of Automata as well, so I'm sure he will be happy to answer any questions after the end of the talks.